Okay, so the macrophages, T cells, B cells. The cool thing about the macrophages is how they are going to become an antigen presenting cell, which is a really cool process. Another type of cell are termed dendritic, dendrites, okay? These are branched. They are going to be mobile antigen presenting cells, meaning when they encounter a pathogen, they are also going to be able to take some of that pathogen in, move it to the membrane, and present it to the cells of the lymph node. Okay? Now, what they're going to do, they will be alerting the immune system that a pathogen has breached a body surface, because they're going to be found in the epidermis, such as, our skin, mucous membranes. Think about the membranes that line all of the openings of your body that reach the outer environment. And they're going to be found in organs of our lymph system. So they'll alert that pathogens have tried to breach the body. They engulf the foreign material. They do it by receptor-mediated. Do you guys remember that one? They bring it into migrate to the nearby lymph node, present what they have engulfed, and activate the immune response. So they are another type of antigen-presenting cell.
But they're not lymphocytes.
No, they're termed dendritic.
Wait.
Yeah. And monocytes. Monocytes.
No, you're saying they're not lymph.
Wait, these
They're not the lymphocytes. They're the
they're white blood cells. Like,
Yes. Yes.
They're what? They're white blood cells?
Well, they are part of this immune system.
So they are a cell of the lymphatic
of
system.
the lymphatic system.
Okay.
Mm-hmm. Now, reticular cells, the difference. Once again, they're branched, but stationary. This time, they are antigen-presenting cells, but they're going to only be found in the stroma of the lymph organs. Think about, for example, the spleen, a lymph node, okay? The inner portion of it, let's think about the lymph node. The inner portion of it, because it has a lot of, now don't confuse a reticular cell with reticular fibers. Do you guys remember that? Okay. However, the inside of our lymph organs, like a lymph node, okay, are branched with reticular fibers. These reticular cells are also branched. So you've got like a branch sitting in the branch, all right? Fluid is moving through that lymph node. Because these cells have the shape that they do, they're simply sitting there in the lymph node. As material comes by, and if they recognize something, they can present it to the T cells there in the lymph node. They don't have to leave. They don't
they're
have
not
to travel.
Okay.
Right. They are just there in the lymph node. They don't have to get out and move around in the tissues, move around in the fluid. They're just stationary in the node itself. Does that make sense?
And since they're branched, they catch stuff and then.
And since they're branched, they can have stuff hang up on them.
But it kind of has to be passed by.
It has to be passing by them. It has to be flowing by in the fluid. Now the lymph tissue itself. Now look what it tells us. We're going to have what we say is lymph tissue. We have lymph fluid, and we're going to have lymph organs. All right? So the lymph fluid is what's moving through the lymphatics. Lymph tissue is where we get, look at what it is, an aggregation. Do you guys remember that term? What does it mean? A collection, okay, of lymphocytes. So it's a collection of those cells, all right, in the connective tissue of mucous membranes. Mucous membranes are the membranes, I'll say it once again, that line the openings to the outside of your body. Why are mucous membranes so important? Yeah, we need to stop things that are trying to invade us from the outside. I mean, think about it. As we sit here right now, we have our nose, mouth, respiratory tract, digestive tract, anus, urethra that are open to the external environment. Mucous membranes are a huge factor in the stuff that we get exposed to. For example, did any of y'all ever pay attention to stuff that swirls around in the light? Okay? Y'all pay attention to that? Okay. What are you breathing in?
All sorts of stuff. Pollution.
The majority of it, over 80% of it, is skin cells. And that means that all that stuff swirling around that light, skin cells from everybody in here. All right? And you're inhaling that, breathing it, just saying. Okay? Now, this aggregation of lymphocytes, which are the white cells, okay, in the connective tissue of the mucous membranes and then various organs, I would say that's pretty important, okay, for all the stuff that we're exposed to from the outside. Under lymphatic tissue, the simplest that we have is diffuse lymphatic tissue. Lymphocytes tend to be a little more scattered throughout the tissue rather in dense, huge patches, okay? So they're kind of spread out, okay? And they're giving a wide area of protection. In our mucous membranes, especially like the body passages that are open, it's referred to as being MALT, M-A-L-T, mucosa-associated lymphatic tissue. Very important in these openings to the body. When we have
Can you repeat that one?
the mucosa-associated lymphatic tissue, yeah, it's written out in your text. I just kind of I kind of reduced it.
It's on page 809.
Thank you.
Oh,
That just means it's like not necessarily what we think of as like uniqueness,
Thank you for
Uh-uh.
asking for
but
this.
No.
it's just like associated with it.
It's think of like having that mucous membrane, which will have the cells that can produce the mucus, okay? Think about that particular membrane and think about this lymphoid tissue sort of just running like maybe just right around it, like right at the area of those cells. Not like all interspersed in it, but like a coating of the lymph tissue, if that makes sense, okay? Now, if it is a dense mass of tissue, it's a nodule, okay? So under the tissues, it can be diffuse or it can be dense. If it is dense, it is termed a nodule. Look what happens. Lymphocytes and macrophages congregate at this area. They're going to be found in our lymph nodes, tonsils, and the appendix. It used to be that, removal of the appendix, they thought, oh, well, no great biggie, okay? It is a vestigial organ, meaning something that was just left behind, okay? But we have recently found out that it does play a part in our immune system. So removal of the appendix does have a little bit, the appendix has a little bit of a purpose, but we can still live without it.
So do they try and treat appendicitis with
No, there's no treatment. There's no treatment.
Well,
It's surgery,
they,
isn't it? You just get your appendix removed.
Yeah, because the last thing you want to do is have that thing burst.
So it's not important enough that like they really need to.
Not important enough. Yeah. Just like with the spleen. You can live without the spleen, but you do have effects. When we talk about a dense mass of tissue, we have some ones that they consider a little special, termed Peyer's patches, which are clusters of these nodules in our digestive system. They're in the ileum and the distal portion of the small intestine. So they're considered, and they're kind of special, most definitely, because of the stuff we get exposed to when we eat. Now, the lymphatic organs of the system. So now, we've had our lymph, okay, which is the fluid, lymph tissue, and now organs. These are going to be the structures, and they are found within capsules. For example, a lymph node. A lymph node is considered an organ.
what do you say that? The lymph node, you said?
Mm-hmm. Now, red bone marrow is considered an organ of the lymphatic system. I know, sounds kind of weird, okay, but remember, blood is a connective tissue. So that's kind of cool. Our thymus, which is also part of the endocrine system, is part of the immune system because of the hormone that helps develop, or helps, I should say, mature the T cells. Lymph nodes, the ones that we tend to think about, we have a bunch of them. One thing that I've tried to point out, we have one-way flow of the fluid, okay? They are concentrated in certain areas of the body, like we saw in the picture. On average, we have about 450 of them throughout our body. Their job, cleansing the lymph and activation of the T and the B cells. Now, we're going to say that the lymph node has a cortex, the outer portion, a medulla, the inner portion. The cortex, look at what it has. Lymphatic nodules. My lymph node with that outer coating, that protective connective tissue enclosure contains my lymphatic nodules, which are dense, okay? And it contains B cells that'll multiply and differentiate in the germinal center of the cortex. The swelling that you get if you're sick and your lymph nodes swell up, okay, it's probably because at this area those cells are proliferating. That's pretty cool. The medulla of the lymph node, like I said, it's got that branching network so stuff can kind of get stuck in it. On the inside, lymphocytes, so that fluid that comes in can pick them up and take them out. Y'all remember how the fluid leaving had a bunch of the lymphocytes in it? Okay? This is where it can kind of pick it up, and as we make our way back to the heart, get those into the bloodstream. Isn't that pretty cool? Now, it's going to have plasma cells, which we will need when we get our specific immunity. It has macrophages that can eat up foreign particles that might be making their way and passing through that lymph node. It has those reticular cells, which are the stationary or located just within the lymph node, antigen-presenting cell. And the inside, of course, has reticular fibers, which is so cool. When you look at that structure, did I not put a picture of the lymph node? Oh, man. Okay, so I forgot a picture of the lymph node, okay? But when you look at that structure, you think of that lymph node, you've got all this branching that occurs. Cells can come in and actually get stuck and hung up to be taken care of in the lymph nodes, which is really kind of cool if you think about it. Another type that we're going to find in the lymph system is the lymphatic tissue, where it's like a patch of it, known as our tonsils. Anybody ever had any problems with those?
Yeah.
Did they remove them?
No.
No? They remove them? No.
It's really rare. They don't like to do it
They
anymore.
don't like to do it anymore.
Yeah, they don't.
Why?
It's like you.
When I was coming along, they rip them out like nobody's business.
With your adenoids.
Okay? Huh?
With the adenoids.
With the adenoids. Okay? Wasn't anything for them to schedule a tonsillectomy. They'd be like, yeah, put them in, ticking things there. All right? Now, why are they not wanting to take them out anymore?
Because it protects you against other diseases or just stuff that's coming into your body.
It's the immunity. Because of where they're located and their structure that they are, believe it or not, okay, they should be a really good defense. If you think about where they're located, hello, we open our mouth a lot, all right? Stuff comes in when we open the mouth. That mucous membrane, like what we think of with the nostril, okay, that's not there. Stuff has a free entry into openings of the body. So, having the tonsils, okay, pharyngeal, palatine, lingual. Did y'all know we had so many? All right, we do, okay. Basically, they have crypts. I love how they labeled them crypts. Makes me think about death, okay? Well, I mean, you know, that's what I think about. But anyway, okay? They are basically these pits, okay, lined with the lymph nodules. The pharyngeal, also known as the adenoids, they're on the wall of the pharynx behind the nasal cavity. The palatine, the posterior margin of the oral cavity, the lingual on each side at the root of the tongue. And their job, catch all the foreign pathogens that are trying to enter and kill them. I just think that's kind of cool. Our spleen is the largest lymphatic organ. It's going to contain red pulp and white pulp, mainly because when you look at it under the scope, that's exactly what it looks like. On the red pulp, it's sinuses, remember empty spaces, and they're full of the red blood cells. The white pulp, now look at what this is. A sleeve. Think about a sleeve that you have on your shirts, okay, of lymphocytes and macrophages. Did that get cut off?
Yours,
Not ours.
not on ours.
Not of the artery, right? Okay, yeah. So, it's actually this wrapping around the blood flow to the spleen. That's pretty cool, if you think about it.
Why are all of these like optional? Like you can go with them. Is it just because there's so many different avenues?
A lot of times, what'll happen is, okay, one of the things they don't like to do anymore is remove the tonsils. Okay, you don't see that happening as much anymore. Now, they'll only remove the spleen if it's pretty much hemorrhaging out. Okay, if they can save it, chances are they'll do what they can to not have to remove it. The appendix, yeah, you can live without that. Okay. Now, if they do have to remove the spleen, what'll happen is a lot of what the spleen has to do, the functions of the spleen, the liver will take over. But that puts a lot of strain on the liver. And it is going to generate health problems for you, for the most part. A reduced immune system is one of the biggest problems with that. Yeah. All right, well, we're going to stop right there for today.
So can I just ask